Good morning or afternoon. Today I'm going to discuss the correlation between Pythagorean Theorem and Trig Identities. Now, most of you guys who are either in middle or high school are familiar with the theorem a squared plus b squared equals c squared. And then you fill with the legs. Now, first, I'm going to show you the three trig functions: sine of theta, cosine of theta, and tangent of theta, or to remember it, SOHCAHTOA, SOHCAHTOA, SOHCAHTOA. Now, so is opposite over adjacent, hypotenuse, opposite over hypotenuse, or B over C, as one would say, cosine, which is the adjacent, over hypotenuse, or A over C. Now, tangent is really interesting. Now, you can either remember tangent as opposite over adjacent, and you probably wonder why is that? Opposite over adjacent. I'll discuss that maybe in another video or later on. Actually, master instead elephant in a room. Now, in some cases, you're going to see tangent of theta, which equals sine of theta over cosine of theta. Now, we know what sine theta equals. Sine theta equals b squared over b over c, while cosine would equal a over c. Or, if you want to be technical, hypotenuse, adjacent, opposite. Now, since tangent sine over cosine, sine equals opposite over hypotenuse, cosine equals adjacent over hypotenuse, because they have a division. Instead of dividing, you can also multiply opposite over hypotenuse, B over C, times hypotenuse, because of the inverse properties. And then you cancel out both sides, and you get B over C, or B over A, or up over adjacent, which is why you get that. Now we address the elephant in the room. Now we have a correlation with the Pythagorean Theorem and Trig Identities. Now you follow with this or whatever, or to find C equals square root of a squared plus b squared. Now imagine if you have to solve the opposite square, or if I actually replace it with the card, adjacent square plus opposite square equals hypotenuse square. Okay, it may not make sense when I put it like this, but you get this little problem: sine square of theta plus cosine square of theta equals 1. And I want to show how it would correlate with the Pythagorean theorem. If sine of theta equals opposite over base, you get opposite over hypotenuse square plus adjacent over hypotenuse square equals 1. Basically, how you would do it, square both sides, get up square plus APJ square over HYP equals 1 times HYP square, because you have square the top and the bottom, and then you get up square plus APJ square equals hypotenuse square, which is why you get something like this, or put another that b square plus a square equals c square. Which is why that makes sense. Oh, dang it. Because you multiply that both sides, one becomes hypotenuse. Replace whatever it is, and you get your answer. Now, keyword Pythagorean Theorem, Trig Identity, one a new subject, how they correlate. You know one formula, you know the rest. Example, if I divide all sides by sine square, then I'll get 1 plus cotangent square theta equal 1 over sine equals h over o, which is cosecant square. Or if I divide everything by cosine, it becomes tangent square theta plus 1 equals secant square theta. Oh, look! You pretty much identify almost everything, or the basic Pythagorean theorem stuff, in matter of one formula. And then we broke down to other formulas. Like if I need to find tangent or whatever by itself, then it'll be tan of theta equals secant minus 1. Or something close to that. And you find out if that's liable, and you plug in the up over odds. So secant is 1 over cosine of theta, which is 1 over a over h, or h over a. Get h over a, and then you get the h over a over j minus adj over adj. Combine the values, hyp minus adj over adj times odds times odds, and then go back up to the top. Go back up to the top. The battery's running low. Up equals a hyp minus adj. And does it look familiar? Oh yeah, it does. B equals C minus A. Oh, same as B squared equals C squared minus A squared. Correlation. For those that don't understand, I'll probably make a video that's better, hopefully, but it is a learning process. Have a nice day.